Morning, students. Morning. Can you hear me and see the screen? That's a yes? Yeah, it must be a yes. That's a response. All right. All right, so let's continue with this revision. So I want us to do 4 questions today. And then I'll share the video, get a chance to redo them, go back over and stuff. And then I'll do the last 4 questions tomorrow. Alright, so that is the plan. So I want us to do quadratics, functions, algebra, etc. right here, and this coordinate geometry. And then tomorrow now, we'll do this one, and the ones on page 3 over here. And that will conclude this exercise, trivial exercise. Alright? So it's all in an effort to help us to remember and to go back over some of what we did from September and so on. Alright, so let's go. So this first question here wants us to factorize these 2 expressions. This one is a quadratic. This one is what we call factorization by parts or by grouping. Alright, so let's do the quadratics first. So this one's a quadratic in P, not a quadratic in X as we are used to, but it's the same process, same steps really. Alright, where we have 2p squared minus 7p plus 3. I want to break this out into 2 terms, this middle term, so we can factorize it, factorize by parts. So again, the process to do that is what we call the AC method. Compare the 2 n coefficients, which is a 2 and a positive 3. So 2 times 3 is 6. Sorry, 2 times 3 is 6. Looking for factors of 6 that add to this middle coefficient of negative 7. Alright. So one factors of a positive number here that add to a negative number. So the factors of a positive number can be either 2 positive numbers or 2 negative numbers. Since we want the sum to be negative, we are choosing 2 negative factors of 6. I'm going to write them down here. The first 2 factors of 6 is 1 and 6. You have to make both of them negative because you want the sum to be negative like that. And they must have the same sign. But when you add negative 1 and negative 6, you actually get the negative 7 already. So yes, that's what you want. So I'm going to break this minus 7p into minus 1p and minus 6p in any order. Alright, so we already found what we're going to split it out into. So this is going to split down. Alright, the expression is going to become 2p squared, and I was splitting this now into, we can use the minus 6p first, it doesn't really matter, or the minus 1p first. So let's say it's minus 1p and minus 6p, and then plus back this 3. I must always do the check that what we split this middle term into is what we're getting back here, which is correct. And then what we have to do now is factorize by parts, the first 2 terms first. Looking for the highest common factor in the first 2 terms. The highest factor in those 2 terms is p. So factorize the p. Out of this, you're going to have 2p left. Out of this, you're going to have negative 1. And as I always say, you want the same thing here to be in the bracket over here. So I normally do is put back the bracket terms. In other words, when I factorize these 2, I must get the same thing that I have in the bracket. Alright, so I'm going to clean this up a bit. So we're going to write back the same expression over here first, which is the 2p minus 1. And then to decide what comes out here as a factor, you can divide, for example, this positive 3 by this negative 1. So 3 divided by negative 1 is negative 3. Or we could have divided this negative 6p by this 2p. Anyway, take it, it is negative 3. Not those 3, you have to put the negative on it. Alright? Then now, the 2 minus 1 the 2p minus 1 becomes a common factor, and they are connected with this p minus 3. So the result then is p minus 3 times that common factor of 2p minus 1. If we put the 2p minus 1 in front, same difference. Same thing, still correct. What good with that?
Yes, sir.
Alright, good. Then part 2 now wants us to factorize this thing, which is 4 terms. So it is 5p plus 5q, and this one has p squared minus q squared. Generally, we will look to factorize these two terms and these two terms. We want a common factor in each of them. Now, if you think about it, there's just a common factor of 5 between those two. But this is not the difference of two squares. So factorizing this part, we factorize it as a difference of two squares, because that's what it is. So I'm going to factorize these two and get factorize the 5 first. Get 5 into, it's going to be p plus q. When I factorize the difference of two squares, it becomes p minus q times p plus q. Right? And then this p plus q is a common factor, and they are connected with this 5p minus q. So those are the two that we're going to connect. That p plus q, the same as we would normally. If this was just, for example, just a value like this 3, same way. So it's going to become 5 plus this plus this. So it's 5 plus the p minus q multiplied by the common factor of this p plus q. And that is it. What I got at that?
Yes, sir.
Alright, that is it, you know. That's the answer right there. So one like this now that could be different because we're having 3 terms inside here, but that's because it's part of it was the difference of 2 squares, right? So that is it. Alright. Next part is for us to expand this expression. Alright? Writing it in descending powers of x, meaning if you have x cubed as a first term, they must have x squared next, then you have x next, and you have a constant next. That's what I mean by descending powers of x. Alright? Expanding this thing. So let's go. So we have x plus 3 squared times x minus 4 to expand. Now, we have to work out this power first. Right? I'm using the BODMAS system, but you have to always work out power first. So it's power first. So we have to basically expand this with the power first. Alright? So we're going to expand that perfect square first. Now remember, when you expand a perfect square, we get 3 terms. First term squared, twice the product of a 2. Second term squared. You have to remember the middle term is twice the product of a 2. So we expand this square. The first term squared is x squared. Then twice the product of a 2 means you multiply these two things first, and you're going to get plus 3x, and you double that. That's why you get twice the product of a 2. Twice the product. The product is 3x, but you have to double it to get the middle term. So you're going to get 6x as the middle term. And then this second term squared, where you square that 3, you're going to get 9. And that is the expansion of that perfect square, multiplying that number by x minus 4. Then you need to multiply these two brackets. And you can look at it two ways. You can take each of these and multiply these over here. So for example, it will be this times this, and this times this, and this times this. Then it will be the minus 4 times, minus 4 times that, minus 4 times that, and minus 4 times that. Or you can do it the other way. We're using these values to multiply those. So you can go minus x squared times that, then x squared times that, then 6x times that, and 6x times that. Then 9 times this and 9 times that. Alright, your choice. Doesn't matter which way you do it. You want to basically focus on getting like terms. So let's say we're multiplying this way. These times this, eh? So it's x squared times each of these first. Hold on a second, guys. Hello? What's up? Yeah, man, what's up? Actually, no, I know. I have classes all day today. But what is it though? Tell me what is it? What is it? Oh, yeah, I understand. What time it was supposed to be? Oh, we'll have some class. I'll call you back later and see if we get through. And see if anything possible. Alright? Cool. Alright guys, sorry about that. Alright, so it's this times this and then this times that, right? We're doing those two first. So it's gonna be x cubed. We'll do this times this. X squared times x is x cubed. Then x squared times minus 4 is negative 4x squared. Minus 4x squared. So we have used this already. Now it's time to use the 6x. So it's going to be 6x times this x and 6x times this negative 4. So 6x times this x is plus 6x squared. And 6x times this 4 is negative 24x. So we're going to get minus 24x. And so we have done with the 6x now. Now it's time to multiply with the 9. So it's going to be 9 times x and 9 times minus 4. So 9 times x is 9x, so it's plus 9x. And then 9 times minus 4 is negative 36. Minus 36. And they basically consolidating the terms. So this is the only cube term there. So it's x cubed. We're putting these squared terms together. So that's like 6x squared minus 4x squared. So it's 6x squared minus 4x squared, or minus 4x squared plus 6x squared. Then when you want to look at it, that's 2x squared. Now you're doing these two, which now is negative 24 plus negative 24 plus 9. So negative 24x plus 9, that's negative 15. Negative 24 plus 9 is negative 15. So you're going to get minus 15x. That's what we get from those two. And then this is the only constant value there. You get minus 36. Why this x better? Minus 15x and then minus 36. That's the expanded form of that expression. That's the answer right there. In descending power. So notice the powers are descending. Squared, cubed, then squared, then x to the 1, and so on. But good at that? But alright?
Yes, sir.
Alright, so this one, if you didn't get it, you can go and work it over, alright? Then we'll come to part C, which is our quadratic function. First part is to give us this quadratic function, and I want us to write it in this form, which is to complete the square. Right, so I'm going to use our method. There are multiple ways to do it, but I'm going to use our xtyt method. So we have f of x equals 2x squared plus 4x minus 5. And when we complete the square, our f of x is going to become a into x minus xt. Hold on a second again, guys. Hello? Can I find it? No? How much was it? Remember how much was it? Alright. I sent you something for you, man. 1 minute now. I give her a thing here. Yeah. No man, I give her 100 and get back 70. Yeah man, I sent you something for you, man. I just don't know the exact figure. But is that right? Yeah, alright. You work it out. Alright, cool. How about that again, guys? I'm at work actually. So alright, so it's a into x minus xt, and then we're squaring that, and then it's plus yt. That's the format that we use. So even though they give us with the a, b, and the c here, that just means that they want us to complete the square. So you're not going to be confused with this a, b, and c, because the a, b, and c that we're going to be using is a, b, and c in the standard form. Alright, that's what we're going to be using. Alright, so the a, b, and c from our standard form is that the a is equal to 2, the b is equal to this 4, coefficient of x is 4, and the c is going to be equal to negative 5. C is equal to this constant term at negative 5. And the xt and the yt are calculated in terms of this a, b, and c right here, like this. So the xt that we want is minus b minus b, minus not coming up, minus b over 2a. Alright, that's our way of calculating the value that's coming here. Remember, it's x minus xt. So even though they give us a plus on there, it's right here. Even though they give us a plus, we are using this method of x minus xt. Because xt is going to be x value at the turning point, yt is going to be the y value at the turning point. That's the method that we use in this formula method. Alright, so putting in the values now. So it's minus, that's this minus. Then the b is just 4. 4 divided by 2 times a, and the a is 2. This becomes minus 4 over 4. Minus 4 over 4 is negative 1. So xt is negative 1. So minus 1 is coming right here where the x is. So it's going to become a plus 1 in there. Then to find the yt value, we can use a formula. But anytime the xt value is a whole number like this, well, that's a negative whole number, you can actually plug it into the function right here to find the yt value. So I'm going to do it both ways as this time to show you. Let me use the formula method first. The normal formula method, which is yt is 4ac minus b squared divided by 4a. Let's use this method first and show that we're going to get the same answer either way. So it's 4 times the a, which is 2, times the c, which is negative 5, and we're subtracting. This is minus, is not squaring. We're only squaring this b, which is 4. Remember now, the square is not on this minus. We're only on the 4, so that's going to become a 16, and this minus is going to stay minus. Alright, divided by 4 times a, the a is 2. We'll simplify this down, yt is going to become, now 4 times, that's 40. 4 times 2 is 8. 8 times 5 is 40. So that's negative 40. That's 16. So it's minus 16. And dividing this now by 8. 4 2 is 8. So yt basically becomes negative 56 over 8. And that works out to be 7, right? Negative 7, yes, negative 7. That's yt. So it's negative 7 that's coming here for the plus yt. But we could work out yt using the function up here. So let's put another method in purple. Or yt would be f of negative 1, because the xt value is negative 1. So plug the negative 1 in there to get the yt value. So we could calculate it that way as well. So it would be 2 times negative 1 squared plus 4 times negative 1 minus 5. We're supposed to get the same answer. So this negative 1 squared is a positive 1. And positive 1 times 2 is 2. So this whole expression becomes a 2. And 4 times negative 1 is negative 4. Then subtracting back this 5. And that becomes negative 9 if you work it out. Because 2 times this negative 4. 2 and the negative 4 is negative 2. Right? Negative 7, not negative 9, negative 7. Right. So this time this is negative 2. Negative 2 and negative 5 is negative 7. So we get the same value. Same value we get, alright? Negative 7. So you can work out the yt value by substituting the xt value in the function. But in any case, that is it now. So based on that, the function then becomes, what does the function become? This function up here becomes f of x equal, the a is 2 right here, 2 into x minus, and the xt is negative 1, so it's minus and negative 1. This minus minus becomes a plus. Don't forget to put on the square, and the plus yt is negative 7. The plus yt is negative 7. This minus minus is a plus. So if you simplify it, it is 2 into x plus 1 squared minus 7. That is your f of x right there. Are you okay with that?
Yes, sir.
Alright. Next part says, state the equation of the axis of symmetry. but it's x equals xt value, right? So that was part 1 that we just did. Part 2 now, the axis of symmetry is x equal whatever the value of the turning point is. So it's x equal -1. That's the answer. This is the equation of that axis of symmetry. X equals -1. X equals whatever the xt value is. Then it says state the coordinates of the minimum point. The minimum point is xt, yt, part 3. Minimum point is xt, yt, which is -1, -7. That's where that minimum turning point is. -1, -7. But the yt value is -7 and xt value is -1, right? -1. This part says we have to sketch a graph and we have to show the minimum point and the axis of symmetry. Alright, so let's work out the sketch now. So function, remember, is f of x equals 2x squared plus 4x minus 5. And we get a minimum point, -1, -7. And the axis of symmetry passes through that minimum point. We also know the c value, right? The y-axis intercept. The y-intercept is 0, c all the time, which is 0, -5. And then because the a is positive, it's going to have a smile shape. So the a is greater than 0, so it's going to have a smile shape. Know that, right? And a positive, the graph will have a smile shape. So let's sketch it out now. It's just a sketch, not to scale. So let's put our y-axis here and our x-axis here. Alright, y-axis, x-axis. Let's get it out in purple. So now the graph has a smile shape, but where does it turn? Where's the turning point? Turning point is this value. Is this as that coordinate, -1, -7. It's a negative x value and a negative y value. So -1 is this way, -7 is down here. So it means that it turns somewhere down here. Alright? So now that it turns in that quadrant. Somewhere down here it turns. And then where does it cross the y-axis? Cross the y-axis at -5. -5 is somewhere down here. So it turns down here and crosses down here. So and it's have a smile shape. You just need to sketch that. Let's do it. So it turns down here, crosses down here. So it must go like something like this. Not this. God, not this. It has to cross somewhere down here and turn down here. So any sketch that does that is good enough. Like that. Alright. I'm going to put in this point as my y-axis intercept 0, -5. That's my minimum point, -1, -7. This time explicitly asks for the axis of symmetry, which is a vertical line through the turning point here. The equation is x equal -1. That's your axis of symmetry. That's your sketch. Right now, that's all I wanted. That's it. Alright. They ask for the rules. If I want to do it, you have to work out the values here. I put in the function equals 0 and solve for those two x values. But that's all I wanted. Are they okay? That question?
Yes, sir.
Alright. Remember, if you did not get it, you need to go and do it. Go and do it over by yourself. Or do it if you did not do it at all. Alright. Number 2 is the second question is a functions question. Alright, let's go. It gives us two functions, two simple functions. F of x is 7x plus 4. That's this one. Second one is g of x equals 1 over 2x. That's this one. First part one is g of 3. G of 3. You're going to take 3 and put it in the g function right here. So it becomes equal to 1 over 2 times 3, which is 1 over 6. Done. Part 1. Part 2 wants f of negative 2. F of negative 2 is what they want. Means they want to put negative 2 in the f function right here. So it becomes 7 times negative 2 plus 4. That's negative 14 plus 4, which then is negative 10. The answer is negative 10. Then I want f to the minus 1 of 11. F to the minus 1 of 11. Alright? You can do this two ways. Alright? You can find f to the minus 1 of x first and then plug in the 11. We can have a method where we just work it out straight. I'm going to do it both ways for you. Alright, part 3. Question wants f to the minus 1 of 11. Alright? So, let's look at it this way. Let's say, let's do it 2 ways. Let's say f to the minus 1 of 11 is equal to some number that you're trying to find. If f to the minus 1 of 11 is equal to a number, it means that the 11, this 11 here, is equal to f of that number. Because if f to the minus 1 of 11 is like the inverse is mapping 11 to n. So it means that the n is mapped to 11 by the function. So if we put f to the minus 1 of n and put it equal to 11, then when we find the n, that's our answer. So what will be the f of n? Remember the f of x is 7x plus 4. No? So the f of n means that we'll plug the n right here. So it means then that the 11 will be equal to 7n plus 4. And you're transposing for this value. Anyway, you have to, any method you're using, you're going to have to transpose to make this position the subject and the value in that position the subject. So I'm going to carry over the 4 first. With 11 minus 4 equals 7n. 11 minus 4 is how much? 7, right? 7 equals 7n. And then divide by the 7, you get n equals 1. N equals 1. Which therefore means if the n is 1, then f to the minus 1 of 11 is 1. So f to the minus 1 of 11 is equal to 1. Right? But I think the traditional way of doing it, let's do the traditional way now. Or we want to find f to the minus 1 of 11. So to do this, we'll find f to the minus 1 of x first, then we can substitute 11 in it and get f to the minus 1 of 11. And that's the traditional way most people do it. So to find f to the minus 1 of the x first, we start with the f equals 7x plus 4. Notice I've left off the of x, and then I form the inverse function. Inverse it. So we're forming the inverse right now. Now the inverse works that this f is range on the function becomes domain on the inverse equals this x is domain on the function becomes range on the inverse. Range on the inverse is f to the minus 1 plus 4. So you see the value in this position here, I want to make it the subject just as I did up here. So whichever method we use, the thing that is in this position need to become the subject. Same thing here. Alright? So we'll make this subject. Transpose the 4 and then divide under the 7. So we transpose the 4, we're going to get x minus 4. Then take the 7 and divide it under there. And that's the f to the minus 1. And put in back of x now, because that's really f to the minus 1 of x. And then we want f to the minus 1 of 11. So we'll plug the 11 in here and plug it in here as well. So it becomes 11 minus 4 over 7. 11 minus 4 is 7 again. 7 divided by 7 is 1. So you get the same answer 1. Whichever method they want to use. Are you good at that? Are you okay?
Yes, sir.
Alright, let's look at part B now. So part B gives us two different functions, right? Part B. It gives us h of x, a simple function again, 5x minus 2, and it gives us k of x right here is 4 over x plus 1. Alright? First part wants h of 0. H of 0 means you plug in 0 in the h function right there. So part 1 just h of 0. 0 coming in the h function there. 5 times 0 minus 2. 5 times 0 is 0, so you left it minus 2. Alright. The second part wants k of 2. Means they're going to put 2 in the k function right here. So second part is k of 2. Putting 2 here in the k function. I get 4 over 2 plus 1. 2 plus 1 is 3. It becomes 4 over 3. Next part wants h to the minus 1 of x. That's the inverse of this function. So simple again, part 3. I'm going to start by saying the h is equal to 5x minus 2. The derivative of x for the time, you're going to inverse it. When you inverse it, the h becomes x. And this x becomes h to the minus 1. Minus 2. We're trying to make this thing here the subject. Transpose the 2 first and get x plus 2. We take this 5 as is multiplying and divide it under here. That leaves h to the minus 1. That's h to the minus 1 of x. So say i.e. that is h to the minus 1 of x is x plus 2 over 5. Alright? Next part says find the value of x if h of k is equal to 1. So all we have to do this, set up h of k and put it equal 1. Simple as that. Alright, so let's go. So solving h of k of x equals 1. Let's write them out again. So the h of x is 5x minus 2 and the k of x is 4 over x plus 1. So doing h of k now. H of k means you put in the k into the h. So this means that we're taking all of this k and putting it into the h right here where x is. So this side, which is h of k, becomes 5 where this x is. I'm putting all of that. We put in a bracket 4 over x plus 1 minus this 2, and that's all equal to 1 over there. No, is 1? Yeah, 1. Alright, I was solving for this x right here. Transposing to make this x a subject. Alright, so multiple ways I can do it. Transpose everything away from, but let's move over 2 first, and then we can divide the 5, or we can apply the 5 to this 4. Alright, let's apply to this 5 to this 4. So I'm going to apply the 5 to this 4 and become 20 over x plus 1, and then this 2 comes over and add to the 1 to give me 3. And then now I can view this as reciprocal, right? So this is 3 is same as 3 over 1. So I can flip this side and flip this side as well. So it means that x plus 1 over 20 is equal to 1 over 3. So I get this on the numerator. I can do that with the entire side. Then to leave this as the subject, I can multiply by 20 first and then subtract the 1. Let's multiply by 20 first. So multiply by 20, I'm going to x plus 1 equals 20 over 3. I take this one and subtract it. We're going to get x equals 20 over 3 minus 1. And then this one is same as 3 over 3. Why did I do that? Because I wanted a number that has the same denominator as this one, which is 3. So I'm going to write x equals 20 over 3 minus 3 over 3. Take this one and change it to 3 over 3. So that I can multiply it by 3 and divide it back by 3. So it becomes 3 over 3. Then I can just focus on the numbers, the numerator now. So it's 20 minus 3 is 17 over common denominator of 3. That's the answer right there. Are you okay with that?
Yes, sir.
Are you good? Alright, so this question
Yes,
is
sir.
done. Alright, good. Let's move down to next question down here. So a number of parts, right? Each part I think is a different question. Right here, let's go. This question gives us this thing to write as a single fraction. So it's x minus 2 over 3 plus x plus 1 over 4. So I want these two fractions to be related. When they are related when the two denominators are the same. So the lowest common multiple of 3 and 4 is 12. I'll put another way. I can take this 4, multiply it up here, and multiply it down here. I mean, the two denominators become the same. And take this 3, multiply it up here, and multiply it down here. So let me show that in red. Multiply this fraction by 4 over 4. Multiply this fraction. So I'll take the 4, multiply it up here, and multiply it down here as well. Then multiply this one by 3 over 3. I can multiply by 1, so multiply the 3 up here and down here as well. So 4 times this x is 4x. 4 times minus 2 is negative 8. Divided by 3 times 1 is 12. Plus 3 times x is 3x. 3 times 1 is 3. Over 3 times 4 is 12 again. Now that I have the same denominator, we can put back that common denominator and just add the numerator values. So it's 4x plus 3x, that's 7x. Then minus 5 plus positive 3. Not minus 5, minus 8. I'm thinking about the answer already. Minus 8 plus 3 is negative 5. That is the answer right there. Single fraction. Alright with that? Very good?
Yes, sir.
Alright. Part D, what we call a binary operation. Simple. So this binary operation star is defined by this. What this means is that star means, let's look at it. This star means the first value goes here and here. And the second value goes here and there. Alright? And they are one of this function, the square and this product. So the value is here, goes here and there. The value is here, goes here and there. Alright? In this example, I want us to work this out. We have to do what is in the bracket first. Alright? So they give us a star b equals a plus b squared minus 2ab. I want us to work this out, right? So we're doing 3 star 4 in the bracket star 1. But we're going to 3 star 4 first. So let's work it out first. So now the 3 star 4 equals, what do? We add them on square. It's 3 plus 4 squared minus twice the product of the 2 of them. Twice the 3 times the 4 equals. Now that's 7. 7 squared is 49. Minus, this is 2 times 3 is 6. 6 4 is 24. 49 minus 24 is 25. This part of this expression is 25. What happens then is that this thing now becomes 25, and the thing in there is 25 star 1. So we're doing 25 star 1 now. So 25 star 1 means you're going to add them, which is 25 plus 1 squared, and then you're going to minus twice the product of them, minus 2 times 25 times 1. Let me shift this over somewhere. So in this case now, this is a A and that is a B. I plug in them in this expression just to see. Sum of the number squared here, sum of the number squared minus twice the product of the two numbers. That's what this reduces to. This reduces to 26 squared minus 2 times 25 is 50 and 1 is still 50. So it's 26 squared minus 50. That works out to be 625, 626. That's the answer. Are you alright with that? Are you
Yes,
good?
sir. Yes, sir.
Alright, good. To go and redo them if we didn't get them right, guys. This one wants us to factorize these two things. This is like a simple common factor. This is like a factorization by grouping. Let's see common factor first. Part 1 is xy squared plus x squared y. So look up the x terms first. Common factor is just x. Common factor, highest common factor is just x. If we got the y terms, highest common factor is y. So combine the common factor is xy into the x out of this is already divided out here, and out of this y squared we already put a y out here. So this is just xy. This is just xy. This is just y, sorry. So the x come out already, and out of this y squared, y gone out here, so you leave back a y inside here. Plus, out of this x squared, the x gone out already, so our x come back in here. And then this y gone out here already. That is it. And this can't be factorized any further. That's the answer right there. But alright to that?
Yes, sir.
Not sure you can expand it back in. Take this time this again, you're gonna get that. And then check this times this, you're gonna get that. So I'm not sure you can just expand it back again in your mind, in a sense. Part 2, we have 2mh minus 2nh minus 3mk plus 3nk. Alright? It's a factorization by grouping. We check the first two terms for the highest common factor first. We want to know the values in a friendly order. So these two have a common factor of 2h. 2h. So you're gonna have m minus n in the bracket. So I want to check if the m and the n is the same order on these two, which they are. So the m here and the n. So you can proceed. Highest common factor in this first two terms is 2h. 2h out of this is m. 2h out of this is negative n. Go by the same thing back to over here. M minus n. Then look. From this you factor down to a minus n. It must be that you factor out a minus 3k. Or look at it this way. From this you factor down a m. So it means that the minus 3k factor out here. And these two connecting your m minus n, so you can write them, consolidate. So it's 2h minus 3k connecting your common factor of m minus n. That is the answer. Are you good at that?
Yes, sir.
Alright, good. We'll come to the simple linear inequality. Remember, the same steps as solving 5 minus 2x equals 9. Same steps. We're trying to make this x a subject as you would over here. Only difference, remember now with this one, because it's an inequality, if there comes a point where you have to multiply or divide with a negative number, you have to remember to reverse the inequality sign. That's a key thing here. Remember to reverse the inequality sign when you divide or multiply with a negative number. So let's go. It's 5 minus 2x less than 9. I want to get rid of this 5 first, so we're going to subtract 5 from both sides. So this 5 gone, therefore minus 2x. And then 5 subtract from this side is 4. But the sign stays the same because I did not multiply or divide with a negative number. I just subtract 5. Same as saying take this 5 and carry it over this side. And get 9 minus 5 is 4. Same difference. Then now to make this a subject, we need to divide by this multiplying negative 2. Because that is negative, we have to reverse the sign. So we want to divide by negative 2 and reverse that less than sign. Divided by negative 2 becomes x. Sign reverse to greater than 2. The 4 becomes negative 2. I divide 4 by negative 2, we get negative 2. This is your solution or your answer. This is the solution for part 1. Part 2 now says if x is an integer, meaning that we have positive and negative whole numbers. If x is an integer, determine the smallest value of x that satisfies inequality. So if x is an integer, what's the smallest value of x that satisfies inequality? We can show it on a number line like so. And put 0, minus 1, minus 2, minus 3, minus 4, 1, 2, and so on. Critical value is at negative 2 right here. There's an unshaded circle on it, means that the negative 2 is not included, and the one value is greater than negative 2, so you're pointing to the right. That's the number line for x greater than negative 2. Now, if x is greater than negative 2 and it's an integer or positive or negative whole numbers, x should start at negative 1. It cannot include negative 2 because there's no equal on the inequality sign. So it starts right here, so taking all the values go this way. It's starting at negative 1. So the smallest value that x can be is negative 1. So the smallest integer is x equal negative 1. If x was not an integer, then you could take any value. Like for example, a value here be good, negative 1.9 here, or negative 1.8 or negative 1.5. Any value that is greater than the negative 2 could work. Because it's an integer, the first integer that is greater than negative 2 is negative 1. That's why that is the answer. Alright with that, guys? Very good?
Yes, sir.
Alright. Then we'll come to this variations question. But direct variations, first thing is k times the second thing. direct. For inverse, the first thing is k over the second thing for inverse variation. Alright, look at it. This is what this one says. It says, table below shows corresponding values of variables x and y. And it's a straight x and y, not y squared, x squared, and like that. This is a direct variation. So it means then, using this one, it's x and y. It's a direct variation. So y is equal to kx. Alright, that's the relationship between them. And this known pair of values is what you use to find k. The k is variation constant. So use the point x equals 2, y equals 12. Alright, so plug them in here. So it means that the 12, which is the y, is k times 2. So if you divide by this 2, you get the k equals 6. So the k equals 6 everywhere up here. So basically then, this and this combine to give us a relationship y equals 6x. Alright, and in order to know that y is equal to 6x, that's the relationship between x and y, you can use that now to work out anything you want. Right, so this y value is always 6 times this x value. Alright, so for the first pair right here, you want to work out the a, the x is equal to 5 and the y is equal to a. So you plug them in there. So the y is equal to a equals 6 times the x is equal to 5. So the a equals 30. And on the second pair here, the x is b and the y is 48. So second pair, the x is b and the y is 48. Again, plug them into that. So therefore the 48 is equal to 6 times and the x is b. Divide by the 6. You get 48 over 6 equals b. 48 over 6 is 8. So you get a equals 30 from here and b equals 8. Those are your answers. Very good? Are you okay?
Yes, sir. Yes, sir. Yes, sir.
It's still a short class. Alright. It's a nice little short class. It's an hour long. Or 15, 20 minutes or more. So we're gonna do this question now. And we'll call it a day. So tomorrow evening at 5 o'clock, we're gonna come and we're gonna do this one, or this, and then ones on this page over here. As I say, right? This. Might skip over this one, like I did this one in class the other day. But let's just jump to this one, depending on the time. Alright, so this one now, and we're calling it a day, guys. This one up here. Right here. Alright. What does this one say? According to geometry, it says a straight line passes through those 2 points. So A is a point 1, 1, and B is a point 5, negative 2. First part 1 is just to find the gradient of a line. Gradient, part 1. So the gradient is rise or run, and the rise is difference in x over difference in y. So the gradient, common m for gradient, of AB is difference in y over difference in x. And let's say we're taking the difference in y by subtracting this minus this. If we subtract them the same way, we're taking the difference in x if we do it the same direction, right? B point minus A point. So it'll be this y value minus this y value. The difference in y, which is negative 2 minus 1 over this x value minus this x value, 5 minus 1. That become negative 3, and 5 minus 1 is 4. So the gradient of AB is that minus 2 over 4. That's part 1. Next part says write down the gradient of any line perpendicular to AB. So perpendicular line to AB is a negative reciprocal. So see the gradient of a perpendicular line is minus 1 over the gradient of AB. So you get that by flipping this and changing the sign. This calculation is done by flipping this and changing the sign. So we're talking about 4 over 3. So flip the 2 over 4, get 4 over 3, and then change this negative to a positive. So it's positive 4 over 3 is the gradient of that line. This part done. This part says determine the equation of the line passing through this point and perpendicular to AB. So part 3, we want to find a line. Let's call it line 2 so we can reference it. Line 2. Our perpendicular line. Let's call it line 2. Line 2 is perpendicular to AB, so it has a perpendicular gradient. And line 2 passes through this point D, which is 3, 2. Let's come off an exam paper, you know. So this is the gradient of a line that you want. That's the point. Those are two things you need to find the equation of a line, the gradient and a point. So good to go. Using the BFF, it's y minus the y value at the point D equals the perpendicular gradient into x minus the x value at the point D. Plug them in that and you have the equation. Nice and easy. So it's y minus the y value at the D is 2. The perpendicular gradient is 4 over 3 into x minus the x value at the D is 3 right here. Since when I multiply this by this, I'm going to get a whole number because the 3's will cancel. I'm just going to multiply this fraction straight inside the bracket. So I'm going to get y minus 2 equals 4 over 3x minus 4. So this time this give me this. And then this times this give me that. It's a matter now of taking this negative 2 into y and make it positive. So we're going to get y equals 4 over 3x minus 4 plus 2. So that reduces to y equals 4 over 3x minus 2. That's the answer right there. And so I must write in form y equals mx plus c, which is that. See there? That is it. Y equals mx plus c. That's it for today, guys. You know, Mr. Sean never give you an early class, a short class. Short and spicy. I'm gonna save these other ones for tomorrow. So tomorrow's class, alright? Tomorrow evening 5 o'clock. We'll do these questions. Okay. And then we'll have completed this phase of our revision. Can do something else again next week. Later this week into next week. I'll send I let you know exactly what we're doing on the holidays, right? But we're gonna have in a class for the rest of this week after tomorrow. Definitely next week. Okay, I'll let you know. I'll let you all know exactly what we're doing. I sent in the group. Everything is recorded. So anybody will miss anything, not a problem really. All the sessions are recorded. But that is it for today, guys. I'll see you all tomorrow, 5 p.m. So redo the questions. Anything got wrong, do them over. Alright? Anything you did not do, go and do it now. More maths equals better maths. Bye bye everybody. See you tomorrow.